why is the idea of time travel so popular? It's been present in our stories long before we even knew what time was. Why are we so enamored by this prospect? The answer should be pretty obvious to anyone who's ever made a mistake in their life. Regret is a terrible feeling. The thought of being able to go back in time and prevent an event we regret, or go forward to predict and then avoid a potential regret, is naturally appealing. However, time travel isn't something we are capable of with our current technology. So, we turn to fiction to live out this regretless fantasy. And narratively, time travel can allow for many intriguing plotlines that wouldn't be possible if the flow of time was strictly linear. It's no surprise that it's such a common trope. Looking through history, science and fiction commonly inform each other. Stories share dreams of the human ambition that scientists strive to fulfill, and scientific discoveries can reveal new potential for stories. For example, humans have always told stories of traveling to the heavens, and the moment humanity gained the technology to do so, that's exactly what we did. Conversely, when wormholes were discovered by theoretical physicists, they were immediately used in starfaring stories as a scientifically proven method of intergalactic travel. This intersection between science and stories is particularly interesting to me, as I have a vested interest in both. Obviously, I love stories. I made this channel for the express purpose of indulging in that interest. And the only thing that kept me alive through my physics bachelor's was my raw love of astronomy and the crunchier side of science. Time travel in particular was an interest of mine, and I'm not the only one. Ever since Einstein's theory of relativity revealed the true nature of time as the fourth dimension and defined the nature of space-time itself, people have been trying to use those equations to prove the existence of time travel. Results have been mixed, but they're fascinating to think about nonetheless. We'll start with the easiest direction, traveling forward in time. Sure, that's the direction time goes anyway, but we're referring to especially large jumps forward in time. The way this appears in fiction, protagonists can jump several years, decades, or even centuries forward to explore a potential future of their world. In the instances where the future is good, this gives the author the chance to explore the positive impact a character can have, which is a great way to motivate a character who may be feeling discouraged by actively showing them the impact they have on others and the world at large. There's also the more fan-service-y approach to this future, where we get to see the character with a family and kids and whatnot. Nothing wrong with that. It can be comforting knowing that whatever the character may face, they'll be okay in the end. These futures are rarely ever altered, except for angst. However, traveling to the future more commonly reveals a dystopia that our heroes need to prevent by doing things in their own time. This is useful because it allows the author to demonstrate what the stakes of the story are by showing the absolute worst outcome. This has the bonus benefit of not breaking the story's status quo, and allowing the story to continue seamlessly forward after the changing the future plot is done. All the angst, none of the consequences. Now to the big question. Is this type of time travel possible? Actually, yes! Soft yes. The catch being that, with this method, there isn't a guarantee you would be able to return to your original time, but getting to the future? Piece of cake. We'll turn to the basic special relativity to explain how this works. You see, the faster an object's relative velocity, the slower time moves for that object. At the speed of light, time stops entirely. This is called time dilation. If Earth is used as the reference frame, a rocket sent into space at near the speed of light could have only a few years pass on board for the crew, but many decades pass for Earth. There is one minor problem with this method. You see, the closer to light an object's velocity is, the more energy that the object requires to accelerate. The amount of energy necessary also scales with the object's mass. So, a massless object, like a photon, can go the speed of light easily, but it becomes much more difficult with mass. Accelerating something as large as a spaceship to the speed of light requires essentially infinite energy. So, if you want your characters to travel to the future, make sure they have a substantial energy source and are fine not going back. Next, going backwards in time. Plots that involve time travel to the past fall into one of two camps. In the first camp, the past cannot be changed, and anything the heroes do in the past has actually already happened. This is a pretty solid approach, as it dodges the majority of the paradoxes involved with time travel, although it has the lovely side effect of spitting directly in the face of free will. It's probably the easiest to write for, as the writer only has to keep track of a single timeline instead of each potential change their protagonists could make to the future, but it can come across as bland and boring. It's the safer option. In the second camp, the past can be changed, and anything, even a small thing, the heroes could do could potentially butterfly effect its way to massive alterations in the future. This type of writing is plagued by the numerous paradoxes time travel brings about and has to wrangle that on top of the multiple timelines. If handled incorrectly, it runs the risk of being confusing and nonsensical, but at least it doesn't bring up philosophical questions like the nature of free will. It's the riskier option. So, is time travel to the past possible in a way that would make it similar to either of these? Let's start with special relativity again. So, if traveling near the speed of light makes time slow, and at the speed of light it stops completely, what happens if you go faster than light? Well, funny thing, really. At speeds faster than light, clocks tick in reverse, and time moves backwards. So, pretty simple. All we have to do is go faster than light. So, how do we do that? Well, all you need is a spaceship made of imaginary mass. How is that possible? Oh, easy! It's not! There is a theoretical particle called a tachyon, which has an imaginary mass, but the key word there is theoretical. We have no evidence that such a particle exists, which makes sense, because it probably doesn't. But if it does, we have a word for it. So, special relativity doesn't really have an answer for us. Instead, we'll look at its more problematic cousin, general relativity. Everyone knows what wormholes are, right? I mentioned them earlier as an example of science that was co-opted by science fiction. There are solutions to the equations of general relativity that allow for things like wormholes to exist. And as wormholes are warps in space-time, that means that not only would they allow one to travel to different locations in space, but also potentially in time. So time travel to the past could be possible through wormholes. A perfect solution on paper. The reality is the existence of wormholes is once again theoretical. None have been observed. The main problem with the existence of wormholes is their instability. In order to keep a traversable wormhole open, it would need negative mass. It sounds like the tachyon all over again, doesn't it? Well, this has a slightly different ending. On a very technical level, we've actually made negative mass. It's called the Casimir effect. I'm going to give a very broad explanation here, but if you find it at all interesting, I strongly encourage you to research it. It's pretty neat. Basically, the universe allows for there to be negative mass in a space as long as the region is still net neutral. So if you put positive space around the negative space, the region will still be neutral overall, thus allowing negative space to actually exist. We've done this before by using two uncharged conducting plates and placing them very close together, but not quite touching. So why hasn't this been used to make wormholes? We've only managed to make a very, very small amount of negative mass. The amount needed to keep a wormhole that is large enough to travel through open is massive, significantly more than we will likely ever be able to produce. So that's it. Time travel to the past is basically an impossibility? Well, yeah. There are plenty of theories and potential ways to travel to the past, but each method is refutable. While there isn't a single specific rule of physics that prevents time travel, the fact that every potential method has shortcomings points to the likelihood that, when we discover the universal equation where all theories are unified, it will refute time travel. But we don't know that for a fact. Sure, it looks impossible. At the end of the day, our knowledge of the universe is incomplete, and we don't know everything. But maybe, when a universal equation is discovered, there will be a way to allow a specific type of time travel to happen, one we haven't discovered yet. But until that Nobel Prize is awarded, keep dreaming and keep writing. I'm going to go take a nap.